Scientists stunned. Google's quantum chip may have tapped into parallel realities. You may have heard the term quantum computing in the news, but do you really know what it means? This technology isn't just another tech trend. It's a revolution that will fundamentally change the way we approach humanity's most complex problems in the next 10 to 20 years. With Google claiming that its quantum chip, Willow, performed a calculation in just a few minutes, that would take the world's most powerful classical supercomputer quadrillions of years, and China unveiling a quantum chip with 504 qubits. It's clear we're entering an era where quantum computing is no longer science fiction. The problem is, most people don't understand what it's all about. Quantum computing is surrounded by mysterious terms like superposition, quantum entanglement, and qubits, which makes it seem inaccessible to the average person. But quantum computing isn't reserved only for physicists and mathematicians. This technology will affect all of us, from how we secure our data online to how we develop new medicines and tackle climate change. Here's why you should understand quantum computing now, before it becomes a part of everyday life. What is quantum computing, and how is it different from regular computers? To understand quantum computing, you first need to know how today's computers work. Every computer you use, phone, laptop, tablet, processes information using bits. A bit can be either 0 or 1, nothing in between. It's the foundation of the digital world. Quantum computers use qubits instead of bits. A single qubit can be both 0 and 1 at the same time, thanks to a quantum phenomenon called superposition. Imagine a coin spinning in the air. While spinning, it's not heads or tails, but both at once. Here's why that's revolutionary. While a classical computer has to check all possible combinations one by one, a quantum computer can check them all at once. To find a specific number in a phone book with a billion numbers, a classical computer might need up to 1 billion tries. A quantum computer would need only the square root of that, about 31,623 tries. That's the difference between seconds and years. Another key quantum phenomenon is quantum entanglement, a connection between qubits that allows them to instantly affect each other, regardless of distance. Einstein called it spooky action at a distance because it seemed impossible to him. Why is quantum computing emerging now? You might ask, if Richard Feynman came up with the idea of quantum computing in the 1970s, why is it only emerging now? The answer lies in technological progress. Qubits are extremely sensitive to external influences. To work properly, they must be maintained at temperatures close to absolute zero and completely isolated from vibrations and electromagnetic waves. Coherence time, the period during which qubits stay in a quantum state, today lasts less than 100 microseconds. This means the quantum computer has only that brief window to complete all calculations before the qubits break down. The year 2025 is a turning point for several reasons. Companies like Google, IBM, and Microsoft have developed quantum chips with more stable qubits. Quantum algorithms have been created that can exponentially speed up the solving of specific problems. Countries are investing billions of dollars into quantum technologies due to their strategic importance. The first practical applications are becoming available through quantum cloud services. How quantum computing can change your life. The biggest short-term impact of quantum computing will be in the area of internet security. Shor's algorithm, written in the 1990s, could break today's most commonly used encryption methods in hours instead of billions of years. This means that everything we currently consider secure, online banking, shopping, private messages, will need to be restructured. Post-quantum cryptography, new encryption methods that quantum computers can't break, is already being developed. Quantum computers can simulate the behavior of molecules at the atomic level, something today's computers cannot do. To model a molecule with just 70 atoms, a classical computer would need 13 billion years. A quantum computer, only a few hours. This opens doors to faster development of new drugs for cancer, Alzheimer's, and other serious illnesses. It also allows for personalized medicine, tailored to your genetic code, and simulation of biological processes to better understand aging. Quantum computers can solve the traveling salesman problem, how to visit multiple locations using the shortest route. This can optimize package deliveries so couriers visit all addresses in less time, improve public transportation routes for buses and trains, and reduce traffic congestion in cities. When can you expect quantum computing in practice? Experts disagree. Bill Gates believes practical quantum computers will arrive in 3 to 5 years. Jensen Huang from NVIDIA thinks 20 years is more realistic. Stephen Bartlett from the University of Sydney optimistically estimates they'll appear by the end of this decade. The reality is this: quantum computing already exists, but in a limited form. Companies like D-Wave have been selling quantum computers since 2011, but they only solve specific types of problems. As for everyday users, you won't have a quantum laptop or phone. Quantum computers will operate via cloud services, much like how you use Google Drive or Netflix today. You'll use them indirectly through apps that give you better recommendations, faster searches, or more advanced AI functionality. Quantum computing will transform technology as we know it, but it won't happen overnight. The key is to prepare for the changes that are coming, because understanding the basics today will help you navigate a world where quantum computing becomes the norm. While we wait for the quantum revolution, you can already explore quantum programming through online simulators like IBM Quantum Experience or Microsoft Quantum Development Kit. Who knows, maybe you will help develop the technology that changes the world. Conclusion: quantum computing is no longer science fiction. It's not just about faster computers. It's about unlocking the deepest secrets of the universe, from the origin of life to the nature of reality itself. So whether you're a tech enthusiast, a student, or just a curious mind, now is the time to learn what quantum computing really is. Because very soon, it won't just be in labs or theories, it'll be everywhere. Welcome to the quantum era.